Hey guys, welcome to lesson number 11. We are focusing on absolute value functions as piecewise functions. These might be my favorite photos on the internet right now. So for today's lesson, you're going to need one extra resource. You just need to get onto desmos.com so that we can graph some stuff together in the second half of this lesson. So I'll cue you in on when we need that. Moving on to what you need for Delta Math. So there are two sections of Delta Math today. One is finding increasing or decreasing domains, and two is writing absolute value functions as a piecewise function. So don't be alarmed. The first one is like a classic section of Delta Math work. The second one, you are required to do 5 problems. Each problem has its own little section. So that doesn't mean that you have a bunch to do. It just means that you have exactly 5 of those problems to do. So moving into the first section. So finding increasing and decreasing domains. So you've already done this. You did it about 2 weeks ago, looking at your exit tickets and just a little bit of confusion that I was noticing in week 4. I want us to talk about what is increasing or decreasing domains. So first of all, finding increasing and decreasing domains is about the behavior of the function. It's not about the location of the function, but how it changes. So in an increasing function, as your x or your input increases, so does your y. In a decreasing function, as your x increases, your y will actually decrease. And so we'll look at some classic examples of that, some more unconventional examples of that, and then do a couple of practice problems together. So just so you know, on Delta Math for this section, when it asks for intervals where it's increasing or decreasing, it will take interval or set notation, which is something I've discussed last week as well, exactly how that would work. Delta Math also has its own videos on that, but I want to make sure that we have a good understanding of what increasing versus decreasing functions are. So if you look at this function right here, you see that as the x increases, the y increases as well, right? That's why when you find the slope of a function like this, it will be positive, because every time you add to your x, you're also adding to your y. Vice versa, on a decreasing function, as the x increases, right, going left to right, x is always increasing, your y is decreasing, it's going down. So once again, we're talking about the behavior of the function. So this is the general shape that you will see that is different between an increasing function and a decreasing function. Functions are not always linear, right? There are other types of functions that can be all increasing or all decreasing. So here's another example of this function that, even though it's not a straight line, right? We're not talking about this green part, but the blue part. This is the whole function. As you go up in your x, as you increase your x, you're also increasing your y. So same thing here, right? Not a straight line, but as you see, as you increase your x, you are decreasing that y value. Another twist, right? You don't always have an all increasing function or all fully decreasing function. Often what you are going to see are functions where one side is increasing and the other side is decreasing. So here's a great example of one that does that. So there's a particular interval at which as x increases, y increases, right? But that's not always true, or else this function will go up, 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 up into the right. However, it flips back around, right? From -2 to +2, this is actually a decreasing function. And then once again, it flips up again. There's another vertex, and so it's going to be increasing. So basically, anytime you see a vertex, you're going to see that there is going to be a change in whether it's increasing or decreasing. So here I'm going to give you an example, and I'm going to take away my little video. I'm going to give you an example of how to describe the increasing or the decreasing intervals on a function. So here I used set notation. Now, notice that when you have a continuous function, a function that keeps on going, you will have overlapping intervals. So notice that -2 is in 2 of these intervals. When you write -2 in both, you are there in both intervals, then you have to make one domain inclusive and the other non-inclusive. Meaning that, for example, here, I made any value less than -2. I made this less than or equal to -2. But then in the next domain, when we were decreasing, I had to make it non-inclusive. Because if this value was equal to -2 at both intervals, that would not be a function. You can't have two y values for every x value. You can't have those overlap like that. Same thing I did here. When we said our decreasing interval ends right before 2, then our increasing is x is anything greater than or equal to 2. Also included this same interval of increasing and decreasing, but using interval notation. Notice that any time that you have infinity, it has to be parentheses because infinity is not a defined number, right? We don't know exactly what that number is. But notice that I use brackets for these. Oh, this should be a bracket. My bad. There should be a bracket right here. And then I use parentheses for these little ones. All right. Go ahead and answer this weekly CFU. Let's go ahead and move on to the second section of the Delta Math. So first of all, this is where you're going to need Desmos.com. So go ahead and pull that up as I go over the first 4 steps of writing absolute value as a piecewise function. So first you are going to graph the function. That's what Desmos is for. 2, you're going to break up the graph into pieces, right? Remember, it's a piecewise function. Then you're going to write the domain, and then you're going to write an equation for each line. So you've already written piecewise functions for your visual. The next thing that you're going to add is that you're just going to graph the function on your own instead of Delta Math giving it to you. So we've got an example right here. So this is exactly what your Delta Math is going to look like. You are going to get this problem right here, an absolute value function, and you are going to turn this absolute value function into a piecewise function. So let's go ahead and move along. All right, so when you get onto Desmos.com and you hit the graphing calculator, you should get right here. And so the function that we had was the absolute value of 2x minus 8. So before we do absolute value, let's talk about what 2x minus 8 would look like. So you can use Desmos on your phone or your computer. It will graph it just the same. So here it's a linear function, right? We have some intercepts, we have the slope, right? But what we want is an absolute value function. So see how it changes when you just add the absolute value, right? So now your function is not a single cohesive piece. It has 2 different pieces to it. You see the slope here is negative because it's decreasing. It's a decreasing function. And here it's an increasing function. So the slope will be positive. So that's why you can turn absolute value functions easily into piecewise functions because it breaks up easily into pieces that have a particular domain and a different equation for the line. So this is why we need to use Desmos so that we can see visually the graph and then we can much easier look at the functions. I also want to show you that if you click on any part of the graph, it'll tell you what the point is, but particularly the intercepts will be very helpful in writing the equations for your lines. So please take advantage of this great resource and let's get back to the actual problem. Now that you have the graph, right, you are going to do step 3, writing the domain. So the same rule applies that I was referring to in the previous intervals as well. You have to make one domain inclusive and the other one non-inclusive. So for this guy, right, we know that if we were to break this function up into pieces, we have to look at the vertex. We have to look at where the function goes from decreasing to increasing or vice versa, or it could go from increasing to decreasing. So for this specific function, see that the domain changes at 4. When you write the domain, you know that the change is going to be x is less than 4 and when x is greater than 4. So you'll see that in the next slide. Then we're going to write an equation for that line. So we see, once again, this is our domain. So we have a piece at less than 4 and a piece that greater than equal to 4. And then you are going to write the equation of the line. This is something you did last week, right? You are going to do y equals mx plus b, and you are going to put the mx plus b in this box right here. So you see that your y-intercept, right? I've got it right here on Desmos. If you click on the gray dot, it'll tell you exactly where that coordinate point is. And so that's at 8. And then if you do your slope calculations, you see that if you start at this vertex right here, every time you go up 2, you're going to the left one. You go up 2, you're going to the left one. That means your rise is 2 and your run is 1, but to the left. So that means it's a negative 2, right? And then you are going to write your equation for your other line, which is going to look something like this. So notice that one line of the function is the negative of the other, right? So now let's do one more example. So you have the thing, I have the steps up on top, right? The first two things you're going to do is you're going to graph the function on desmos.com, and then you are going to break the graph up into pieces. So go ahead and take a second to do that on your own, and then let's meet back up and talk about what the domain would be. So you should see that the domain changes exactly at 7. So you are going to have the cutoff be at 7. Make sure that just like we talked about before, you're going to have one inclusive domain and one non-inclusive domain. So for this one, right, I flipped it. I made the inclusive domain in the first one. It doesn't matter which one you do as long as one is and one isn't. Then you are going to write an equation for each line. So go ahead and take your own time, write your equations for the line, answer the questions, and then we will move on. Here is the answer for this one. All right, folks, that's it. I hope this helped. Let me know if you have any questions, and good luck.